Hello, my name is Shai Rothfeld, and I am the head of QA department at Traffix Systems. Thank you for viewing this short demo to get a small glimpse of the amazing functionality of the Traffix Signaling Delivery Controller, or SDC. First, a few words on the Traffix Signaling Delivery Controller. The SDC is the market's only comprehensive diameter solution with full functionality for diameter routing, diameter load balancing, and diameter gateway. A DRA, DEA, IWF, all in one. In addition to its full real-time functionality, the SDC offers operators unbeaten top performance and the market's highest ratio of value to cost and best capacity to footprint. The SDC supports the widest range of message-oriented protocols for routing and transformation, such as SS7 and SIP, and support more than 50 diameter protocols. And the SDC is hardware agnostic, running on off-the-shelf hardware. There are many network use cases that apply to the signaling delivery controller. However, in this demo, I will give you a taste of one functionality, and that is the IWF, Interworking function, that enables multi-protocol routing and transformation, or in layman's terms, a process that is used to interface data sent between a wireless system and a telephone network. This IWF functionality is between map-based and diameter-based interfaces according to the 3GPP TS 29.305 v9.0.0 specification. The specific scenario is update location. So let's begin the demo. The following topology illustrates the scenario that we are about to emulate. As you can see, we have three entities playing different roles. There is an SGSN element, the interworking function entity, and an HLR element. The flow begins as the SGSN sends update location request over S6 diameter interface towards the interworking function node. The interworking function node converts the SGSN's diameter request into map SS7 interface corresponding request message type called update GPRS location request. The HLR sends insert subscriber data request towards the interworking function node, which then replies back with a return result ACK message. Finally, the HLR replies the UGLR message sent earlier with UGLA message. Now that the communication between the interworking function node and the HLR using map SS7 interface is over, the interworking function node replies to the ULR sent by the SGSN at the beginning of the flow with ULA message, and the flow execution is completed. The emulators used in this demo are the actual ones used in Traffix R&D. First is the SGSN element that is emulated by the JMeter application that Traffix uses in its diameter testing tool. Here we can see the two samplers used for capabilities exchange request and update location request, followed by the AVP's content. For example, here we can see the AVPs of the update location request command, such as SGSN number, username, and their values, respectively. All this is made possible by the Traffix SDC, which controls its entire configuration elements and its various functions in one central location. For example, in order to add the HLR peer, I shall go over to Topology, Remote Peers, and press the Add button. In the Opened Properties window, I shall add the peer's name and protocol. Then I shall press the Next button and add the following values: host IP addresses, port, local IP addresses, SS7 address, and module ID. Finally, I shall press the Finish button. In order to deliver the SGSN traffic to the HLR, I shall set a routing table using the routing section. The use of customized rule attributes entries allows me to create rules per specific traffic type, in this case, based on the username value in a specific range. The third element of HLR is emulated by a generic HLR simulator. Now, I will activate two Wireshark sniffers, one on the interworking function node and the other on the HLR simulator. I press the Start button and initiate the SGSN request. Here we can see that capabilities exchange process is over and also the confirmation for send-receive actions of ULR/ULA messages. I will now go back to the sniffers and stop them. On the interworking function node, we shall filter diameter type of messages from the packet capture. Here we can see the capabilities exchange process followed by the ULR and ULA messages between the SGSN and the interworking function node. On the HLR simulator, we shall filter TCAP type of messages from the packet capture. Here we can see the UGLR message arriving from the interworking function node. The insert subscriber data request is sent by the HLR, which is acknowledged immediately. And finally, we see the UGLA message sent by the HLR to the interworking function. For a more detailed demonstration and explanation of our SDC, please fill out the form and we'll be in contact with you. Or visit our website on www.traffixsystems.com.